like that.
Yeah, and he said that he may or may not jump on, so.
Yeah.
Okay, so we're gonna go ahead and start the group meeting quiz. Okay, so question 3, the true linear regression equation is y equals beta 0 to beta 1 x, where beta 0 and beta 1 are unknown. What are the null and alternatives hypothesis for beta 1?
That's a good question.
Let me look in the reading.
Wrong keyboard. Okay, the null is going to be equal to 0, and alternative is not equal to 0.
Not equal, so the third option.
Yep.
Okay. Okay, a residual is?
It's defined as the difference between the observed value of y and the value that would have been predicted by the regression line. So, yes, the third option
The third
is
option.
the difference between the observed value y and the value predicted by the regression line.
Okay. Yep, that's correct. A plot of residuals supports using linear regression when the residuals look normally distributed. The residuals are all positive. The megaphone shape. So there's a pattern.
Will show no patterns and will consist of random scatter. Okay. If linear regression is appropriate, then the residual plot will show no patterns and will consist of random scatter. So
it doesn't have in no, that's not an option here.
Yeah.
Is it normally distributed?
Oh, megaphone.
Megaphone?
Right there. Yep, there are several patterns that could arise in a residual plot: curvature, megaphone, and outliers.
Okay, is this in? Oh, right here. Yep. Megaphone. Okay. For the next 8 problems, use the data. Download this. Okay, and then are we doing a linear regression on this? Use the confidence variable as the explanatory variable and the score variable as the response variable. Clear contents.
There it is. Sorry, I might be a little slow on this one. I'm still waiting for Excel to open.
It's okay. I had to clear out all the contents, so I got it in here. Okay, what's our next question? Compute the residuals for the data using software. What statement best describes the residuals? -42. -40 to 25. I don't think that's correct.
So I guess the second option, so just
I
form a
think
linear
it's
pattern.
linear. I think it's linear pattern.
Yep.
Based on the QQ plot for these residuals, what can we say about these residuals? I think they're fairly normal,
Okay.
right?
Yep.
Is that what you guys would say?
Yep.
Use the software to create a scatter plot of the data. Given the scatter plot, residuals plot, and the QQ plot, which 5 assumptions about linear regression are satisfied by this data? Would you say there is a linear relationship?
Here, I'm just finally copying stuff over. So give me just a second and I can be of some use at least.
I think there's a linear relationship and that the residuals are normally distributed.
That's what I'm thinking.
Okay.
Because the other ones really don't make sense. Variance error.
The variance of the error term is constant for all values of x. I'm not sure what that means.
Observations are independent.
Okay. Yeah, I'd say there's a linear relationship. The variance not constant. Here, give me just a second. I'll be right back.
Okay.
Sure. For question 9, did you get 12.695?
For B1, yep, 12.695. Now construct a 95% confidence interval for B1. Input your answers in the lower bound and upper bound.
Okay, I'm back.
So
Sorry.
the lower bound, I got 742.772. Okay, Ben, so on 8, I just put there's a linear relationship between x and y. The residuals are normally distributed. I don't know what the variance of the error term is constant for all values of x. I'm not sure what that.
I don't know either, but I'm not really seeing anything constant about it.
No, and I don't think I didn't see it in the reading, scanning through it really quickly. So, and I don't know about the observations are independent. I don't know. So I just put those two and then I can submit and see if they're correct or not.
Yeah, that's fine.
And then so B1, we have 12.695 for question 9.
Yes.
Question 10, for the lower bound, it's 742.772. The upper bound is 995.712. Let me double check that really quick. 995.714.
Wait, was that for 11?
for 11. 995714. Based on the
did you
evidence using the significance of 0.05, what decision would you make regarding the hypothesis test for B1? So would this be our R score, which is 0.728?
I believe the R was. Yeah.
And so our R value is greater than, is that our P value?
Yeah, I think it's essentially the p-value for linear regression.
Okay, so failure to reject the null hypothesis test because the p-value is greater than our level of significance.
Yes.
That's what I'm gonna put. For the B1 hypothesis test, if you reject the null hypothesis, what does it mean? Okay, hold on. Where's our HO?
Sufficient evidence. There's sufficient. It's not.
Okay, so if we
that
reject,
that would
Oh, go ahead.
there would be sufficient evidence to conclude that the slope of the rejection line is not 0.
I think so.
Because if B1 is equal to 0, then
That's the null.
that's the null. So if you reject the null, you would say there is sufficient evidence.
Yeah, there's enough to say that it's not.
Yes. Okay, here's another Excel sheet.
Sorry, for number 10, what did you get?
Hold on, sorry. Number 10, I got 995 points, number 10 is 742.772. For this data, which variable is the dependent variable? Probably body
hold on.
length.
Hold on. For question 10, just curious, I'm looking through stuff. Where did you get the 742.772 from?
In the linear regression, I got confidence interval for mu y. Is that the wrong one?
Because I'm getting, for my confidence intervals, I've got 91.139 and 98.579.
Yeah, that's what I'm getting too. Great.
Maybe I got
So
the wrong ones then.
you might have them backwards. Let me check something real quick. For X, do you have, let me find it. The confidence variable is the explanatory, which is X.
Yeah, my first is
The other
4.34.
Okay.
Did I copy
Weird.
them wrong?
I don't know.
So confidence variable is the explanatory variable, and then the score as response.
Yes.
So let me open this spreadsheet again. So our score is response. So that would be Y.
Yeah, the first one should be like 50 and then 83.3.
Yeah, that's what I have. And then my explanatory, I have 4.34 is the first one.
Yeah.
And so is my data? Should I close this spreadsheet and try it again?
I don't know. Maybe.
Okay.
I mean,
well,
I could be doing it wrong too. I don't know.
No, I doubt it. I had.
So
Let me try this.
I'm getting the same 91.139, 98.579.
okay.
Yeah.
So
if
why don't
Sam
we
has the same.
try? Why don't we try that one, and I'll submit first and see how it goes.
Okay. So what was the?
For 10, we got 91.139. And 11 should be 98.579.
That looks better.
And then I don't know, did you get 12.695 for 9?
Yeah.
Okay.
So 98.979.
Yeah.
Okay.
And then I don't think anything else changed.
Okay. So now we're on question 14 for this data, which is the dependent variable. I would say it's body length.
I'm pretty sure it is.
Because we're using head as our predictor or our explanatory. I would say.
Okay.
I'm just copying this over. Okay. So for what's our next question?
Okay.
There.
Oh, hi. Is this
Determine
this is the same question?
the margin of
Okay.
error for the 95% confidence interval. Input the lower bound and the upper bound. So how do I get the margin of error?
I think we're still just popping stuff in there. Sorry, I'm double checking something real quick. So the explanatory variable is going to be the head length. So yes, okay.
And then the margin of error would be the upper bound subtract the lower bound divided by 2.
Yes.
Is that correct?
Yep.
Divided by 2. Did you get 17.896?
Sorry, I'm still copying stuff.
That's
Okay. So
Is that lower bound minus upper bound divided by 2?
I did the upper bound minus
upper
the
bound
lower
minus lower bound divided by 2.
Oh, divided by 2. I got. Wait, what?
Okay, so the upper bound should be 7.439 minus a negative 57.377. I think.
Okay, am I looking at the wrong confidence interval here?
I honestly have no idea.
So on this spreadsheet, when you look at it, do you look at the confidence interval for mu y, or do you look at the confidence interval for B1?
I'm looking at the mu y one.
Okay, because so my confidence interval, I have 9.791 and 45.583. Is that
Huh.
wrong?
That's not what I have, but I'm not 100% sure that I'm doing this right.
I don't know, because I'm
So-
just using the formulas in the spreadsheet.
Yeah.
And I'm on the
Um,
linear regression t-test.
yeah. I'm on the same tab. I'm just looking at the lesson 23. It does the whole crocodile method thing.
Uh-huh.
And it's the body length variable and the head length is the x variable. So that's what I copied over.
Yeah, so the head length you'd have 24, and then the response you have 161 as your first.
Am I looking at the wrong one?
Hey, can you guys hear me?
Yeah, hi.
Yeah.
Sorry, I just couldn't get away from that meeting. I did the entire quiz this morning. If you guys haven't finished already, I know I'm kind of late.
No, that's
Well,
okay.
geez, Mitch.
Sorry, I just
No, you're totally fine.
We're almost done. We're
We
just
are on
the
question
last-
15.
Yeah.
Do you want me to just give you the answers?
Well, yeah, we want to know if we did this correctly.
Sure, if you want to pop them on over. I've got a senior project to finish.
15 is 0.443.
0.443. Okay, how did we get this?
That's what mine was totally wrong.
So I'm wondering if it's
Oh my gosh. Yeah, we're looking at the wrong one to begin with
yeah,
because we are supposed to be doing B1. It's the
B1.
slope. Yeah.
Yep. Okay.
Lower bound 7.218.
Okay.
Upper bound 8.103. And then 18 is we are 95% confident the confidence interval.
Okay.
17 is 8.10.
Do we want to go over from the beginning, see if you guys got the other ones right?
Yeah.
Sure, why not?
I only have like a minute left.
There you go.
3 is null is B1 equals 0. Alternate is B1 does not equal 0.
Yep.
Okay.
4 is the difference between the observed value y and the value predicted by the regression line.
Yep.
Okay.
5 is the residuals look normally distributed.
Okay.
6 is the residuals are between -40 and 25.
Okay.
7, the residuals are fairly normal.
Okay.
8 I couldn't figure out,
Okay.
but that's the only one. 9, 12.695.
Okay.
10, 10.674. 11, 14.715.
14.715.
12, reject the null hypothesis because p-value is less than the level of significance.
Okay, is
13,
R the p-value? Or what's the p-value?
I think the p-value is the p-value. There's like a...
Oh, there is a p-value. Never mind. Yep.
Yeah.
I see
Okay.
it. Yep.
14, body length.
13 was there is sufficient evidence.
13, there is sufficient evidence to conclude that the slope is not 0.
Yep.
Okay.
Body length. Yep.
All right, guys, I got to go, though. We're starting back up.
Yep. Okay, bye.
Bye.
Thanks, guys.
Okay, do you want me to submit?
I can submit. Oh, we were so wrong on those two.
Yeah, I was looking at the wrong ones, so now I know where to look.
That's funny. Okay, so 8 we did not get correct. Other than that, Mitch was right.
Oh, what do you think I should check? The variance, the observations are independent.
Let's see. Use software to create a scatter plot of the data.
And then I'll have to go through this reading. The residuals are between -40 and 25. I'm not sure. I'll have to relook at that. The variance. Okay, which other one should I check? Because I'll submit. Should I check that they're independent?
Sure.
So I'll check those three. If it's wrong, then we'll have to do something else.
Yeah.
Nope. I checked there's a linear relationship between x and y. The residuals are normally distributed and the observations are independent. So that's not correct. So
Guys, my connection is really bad, and I heard kind of Mitch came in, but then I was kind of kicked off.
Yeah, you're good. We'll go ahead and go through them all for you. So question 3 we had right, and it's the third option. Question 4 is the third option, is the difference between the observed value. Question 5 is the residuals look normally distributed. We were totally wrong on that one. It's the first one.
Okay.
Residuals look normally distributed. 6 is the residuals are between about -40 and 25. 7 is the residuals are fairly normal. 8 we're not sure on. We're playing around with it. 9
Okay.
is going to be 12.695.
All right.
10 is 10.674. Oh, that's what we were doing wrong. Yeah, I get it. It's 10.674 for number 10. 11 is 14.715. 12 is we reject the null hypothesis test because the p-value is less than a. 13 is the fourth option. There is sufficient evidence to conclude that the slope of the regression line is not 0. 14 is going to be body length. 15 is 0.443. 16 is 7.218. 17 is 8.103. And 18 is we are 95% confident that the confidence interval will contain the true value of B1.
So, like for number 10 and 11, like.
The problem is we were looking at least I was looking at the confidence and prediction intervals for regression response.
Yes.
I was looking at those boxes. We were supposed to be calculating the slope.
Yeah.
So it should have been the B1 section.
Yeah, confidence intervals.
Yep.
Oh, I see. Okay.
So we were looking at the wrong one. That's why.
Got it.
Okay. So